All right, exercise 5B. So you should have a page somewhere. I want you to write down exercise 5B. So here we go, exercise 5B notes. Here we go. Now let's start off with some concepts here. Back in primary school, the first operation you learn is add. That's the first thing you learn to do. And you count things, so you're adding things. So we'll start off with 2 plus 2 plus 2 plus 2 plus 2. What does that equal to? 10. Because you can either add them, which go 2 plus 2 plus 2 plus 2. You can count them. It becomes 10. But someone also said a shortcut to this. What's a shortcut to writing 2 plus 2 plus 2 plus 2 plus 2 5 times?
5 times 2.
5 times 2. Because you're saying you've got 5 groups of these 2s. Now what I want you to see is that the reason why this came about is because we are lazy as mathematicians to write 2 plus 2 plus 2 plus 2 plus 2. There has to be a faster way of doing this. So we call this simplifying the problem. And what you're doing here is you're writing 5 groups of 2. And it means 5 times 2, which is still 10. But it significantly reduces the amount of times you have to write 2. Agreed? Okay, now, it's the same thing with algebra. Algebra, remember, pronumeral is a letter that represents a number that you don't know. So I can do the same thing again. I'm going to do A plus A plus A plus A plus A. How many A's do I have? 5 of these A's. So I know I've meant to say a shortcut of writing this.
A times 5.
Very good. Or 5 groups of A. Can you see the pattern? It looks exactly the same. We just don't know what this number is. But whatever this number is, I'm adding itself 5 times, just like you had 2 plus 2 plus 2 plus 2. There had to be a shorter way of writing this. Now, if I asked you how many 2's you have, you were able to count them. You said 5. But how did you do it? Because the plus and minus signs separate the number of terms. That's why when you ask me, is it separated only by plus minus? Yes, because when you add and subtract, that's what you're doing. You're adding the groups. So this is your term, 1, 2, 3, 4, 5 terms. And when you deal with algebra, it's the same thing. You've got 5 terms here, 1, 2, 3, 4, and 5. What you've done, listening, what you've done here is you've made 5 terms and you simplified it all into one expression. You see that 5 times the A is much shorter than writing 5 of these A's. That's why when you ask me how many terms this is it separated by a times or not? It's not. 5 times A, we don't know what that is. And as mathematicians, we're too lazy to write 5 times A. So this is what we write. 5A. Okay, this is the reason we just write 5A, because we're too lazy to write 5 times A. Now this is key for you to listen to. Eyes and ears towards me. Eyes and ears towards me. Active listening or active notes. You see here, when you say 5 times A, we don't know what that answer is. We don't know the result. But we're too lazy to write the times symbol. That's why we just write it as 5A. But really, between the 5 and the A, there has to be an operation. And the operation is times. Okay, so if you go back to what we were writing before, where I had up here, I wrote before something like 3AB. I'm going to add another one now. Z. This is a lazy way of writing 3 times A times B times Z. We're too lazy to write that. See, that takes too long to write. So we as mathematicians wanted to shortcut that, and we write it as one term, and we just write 3ABZ. And that's why when you see them in an expression, this is considered one term, because this is one term. This is 5 terms, 1, 2, 3, 4, 5. That's one term. This is one term. Okay, so that's why when you ask me, how do you know how many terms you have? It's only separated by a plus and a minus sign. Not times and not divide. Because times is actually simplifying it. That's what you're doing. You're grouping them together. Okay, so write those notes down to help you remember that. If you understand why you have 5 terms up here, you're doing the same for algebra. It's the same thing, same concept. Okay? Yep. I'm just moving this aside to make it look nicer. Please write this down. Please write this as part of your notes, because then it'll help you understand when we start doing exercise 5B. That's my Z. Yeah. I don't know, that's how I learnt it.
That's not good. Did you get a haircut?
No, that's why it's long, and also it's cold, so I just wore a beanie. Please copy the notes down. What I want you to pick up there is that this is a simplified version. 5A is one term. We're combining 5 terms into one term. One term. I'll write the side here. This is one term. Okay.
What is the term for times again?
Oh, you mean the language? Product. Products of, times, groups of. Yeah, but products. Product is multiplication.
Mr. Tran, is it 3 times A times B times Z, or is it 3 times A, 3 times B, 3 times Z?
No, this is just 3 times the A, whatever that is, times it to B, and then times it to Z. Yeah. Whereas what you said before was 3 times A, and then 3 times B, so you're doing another 3. Yeah.
So it would be, so say A was 1, B was 2, Z was 3. It would be 3 times 1 is 3, 3 times B is
And B was 2.
and then 6 times 3, 8.
Good. Very good. That's what we're doing today.
Would it be the same no matter what way around it goes?
Correct.
It would.
Yep, and that's called commutative law, which I haven't mentioned here. They're trying to tell you that A plus B or B plus A should be the same, or A times B or B times A is the same.
If you did 3 times 3, 9. Oh yeah, it would.
Yeah, if you did 3 times 3 times 2, doesn't matter which order you do it,
And then times 1.
should be the same. Yeah.
3 times.
Yeah.
So no matter what it is, times tables.
And addition. So addition and multiplication, it's only subtraction division, it doesn't work. Yeah. That's called commutative law. Alright team, here we go. 5B. Let's write some examples. So, let's have a look at these 2 expressions here. I want you to copy these expressions down. Example 3. Let's have a look at A. Shh. Eyes and ears towards me, actively listening or actively writing. Here we go. Example 3, A. You have 5x. 5x. Listening. Chris. Cooper.
Eyes and ears towards me. Would that not substitute X for 3?
Very good. Now, listening. So with this example here, what I wanted you to understand is 5 next to the x, even though you don't see the operation to it, what's actually happening between the 5 and the x? What are we saying? What's the operation? Times. We're just lazy to write it. So, in your notes, I actually want you to physically write it as 5 times x. And now, in the question, they said that x is equal to 3 and y is equal to 6. Now, when they say evaluate, they want you to find the overall answer. Whenever a question asks you to evaluate, that means there has to be a numbered answer. Never will they ask you to evaluate something that you won't get a numbered answer. So if you don't get a numbered answer, they ask you to evaluate, you've done something wrong. Okay, so every time they say evaluate, there has to be an answer here. It has to be a numbered answer. So it can't be 5x and it can't be 5 times x. When they say evaluate, you should get a numbered answer at the end. Now we know that x equals to 3. So what this question is really asking is, what is 5 times 3? And we know that 5 times 3 simplifies to 15. Very good. That's a numbered answer. That's what they mean when they say the word evaluate. You should expect to get a numbered answer. If you don't get a numbered answer, you're doing something wrong. If they ask to simplify, then 5x was simplified already. Okay? If they ask to solve, you can't solve. There is no equation. There's no way you can solve this. It's 5 times something. We don't know what the answer is. Okay? But in this case, we do know what it is because they told us that x is equal to 3. So it makes sense that now that would make it 5x would equal to 15. Let's try B. B says you now have 5x squared plus 2y plus x. Now let's break this apart. 5 next to the x squared. What does 5 next to the x squared mean? What's happening between the 5 and the x squared? It's timesing. Very good. So I want you to write it out. Be very clear with your working solution. It's 5 times x squared plus, now 2 next to a y. What does that mean?
2 times 1.
Very good, Logan. So it's 2 times the y plus x. See that? Now, we can start filling in the numbers now because we know what x is and we know what y is. Here we go, 5 times, now x is 3, so it's 3 squared. Now notice, look at my notation. I don't just write the 3 with a squared, I write the 3 with the brackets in, and I do that on purpose. And I want you to copy that down with the brackets as well. Don't do the shortcuts. Because it's the shortcuts that my students in year 11 need to fix now. They often get mistakes. Notice that you can only square, and what you're squaring is just the 3. It matters. Okay, because there's a difference between if you had something like 3x, sorry, let me just write that again, negative x squared. Is this squaring the negative x, or is it squaring just the x? It makes a difference in the answer. So if you had minus 3 squared, this is what happens in my year 11s. You see, when they see that, they will think the answer is positive 9, and it's wrong. Okay, because what they're not seeing is if they wrote it in brackets, it will make sense why the answer is not plus 9, but it should be a minus 9, because that square should be this. That's what that's saying. Okay, so 3 with a square. Remember BODMAS or BIDMAS, brackets, indices, then multiplication, division. Here, indices comes first before subtraction. That's why it is 3 squared first, and then you times it by the minus. That's why it's meant to be negative 9. What my students are doing, on the other hand, is they think this means that. That's what they're thinking. That's why that's wrong. So negative 3 squared would mean negative 3 times negative 3. That's why they say it's positive 9. But I didn't put a brackets there. Okay, so brackets are very important. Make sure to get in the habit of every time you're squaring, put in the brackets. Okay, so I'm putting in the brackets here. It is not just x squared, it is 3 in brackets squared plus 2 times, and now y was 6, and plus x again, which is 3. See what I'm doing there? I'm just replacing all the x's with a 3, we're replacing all the y's with a 6, and this gives me a new expression now. 5 times, now what's 3 squared? 9, very good. Plus, what's 2 times 6? 12 plus the 3. So I'm just going to write here so you can see what I'm doing. All right, so break it apart. Do your BODMAS. This is where BODMAS matters. You got your bracket, so 3 is still there. 2 times the 6 is 12. 3 squared is 9, and I still need to figure out what 5 times 9 is. Okay, don't do 5 times 3 and then square it. Brackets, indices, multiplication, division, add, subtract. You always have to go in that order. Okay, so we're going in that order. 3 squared first, so indices first. Then you're going to times the 5, so 9 times 5. What is 9 times 5? 45, very good. We've got 45 over here. Plus the 12 plus the 3. Let's work it out. What's 45 plus 12 plus 3? 60, very good. Okay, so be mindful when you're doing this. This is what exercise 5B is. It wants you to understand 2 things. It wants you to understand a number and a letter next to each other. If you don't write anything in between it, it means it's timesing. Over here, they want you to follow BIDMAS or BODMAS. Okay, so your orders of operation matters, and you need to be able to understand the 5 or anything next to each other without any operations is always times. So for example, in the year 9 content, you will get something like this. You might get a problem where it looks like, actually maybe I'll do it an easier way. Okay? It doesn't even have to be a letter. If you see something like this, okay, have a look on the board, have a look on the board. If you see something like this, I want you to understand that the -2 next to the bracket actually is a times. So even if we don't write it, it actually means times. We're just lazy to put it in. This actually means after you square the 3, which is a 9, the -2 over here, you're multiplying these two together. What I find that most students tend to do as a misconception is when you got two numbers and you don't know what to do with it, you guys add. That's the common mistake that most students do. We're kind of very good at adding, and so a lot of students just add the two numbers together. Don't add. If you don't see a symbol anywhere, anytime between anything, it is multiplication. Okay? It's multiplication, not addition. Very good. Copy the notes, because that's what exercise 5B is about. This is exercise 5B. Substitution. 5B. 5B, make sure to copy it down. And if you can't, it's on OneNote, so you can always refer back to OneNote. All right. Let's do one more together, and then I'm going to give you your time to practice these exercises, okay? 5A, 5B. So here we go. This is 5B, question 3. I'm going to do the one with a fraction there. So H. We're going to do this one together, so copy this down. 3H AB over 3 plus B. Let's do this one together. So this will combine what you've been practicing together. Let's see. Let's do this together. So write the question down. 3H. You got AB over 3 plus B. Now, first thing, in your notes, when you write an A next to a B, what does that mean again? What does it mean when you write an A next to a B? What are you doing? A times B, very good. A next to the B means A times the B. Write it out. Don't be lazy with it. Write it out. If you're lazy with it, you can actually just use the brackets and put in the numbers. Okay? That could also cut down your working solution if you want. But that means A times B divided by 3, and then you add B. Let's put them all together. What is A equal to? They told you up here. A is 4, and B is -3. So I'm going to write them out very slowly for you to see. So A was meant to be 4. A next to a B means times. So I'm timesing it with B. What's B again? -3. So it's 4 times -3, and you're dividing that by 3, and then you're adding on B. Now what's B again? 3. Okay, be careful. It's negative. Now I know that looks scary, but it's not. If we take our time, let's break it apart and do it slowly. Let's do it together. When you're working out this fraction, you need to work out the numerator. What's 4 times -3? It's going all the way back to term 1. Good, minus 12, because this is a positive number, and that's a negative number. Positive, negative is minus. Very good. 4 times 3 is 12, so -12. Over 3, now notice here, this is plus and a minus. Instead of writing plus minus, I can write it as what? What's plus minus the same as? Minus. So I can write over here, -3. Now that fraction there looks scary, but that's okay. Let's work it out. Can we simplify -12 over 3? This just means -12 divided by 3. What's -12 divided by 3? -4. Very good. So here I can now say that's -4 minus 3, and making sure that your integers are okay, use a number line in case you make mistakes. -7. Very good. So you can see this is a combination of everything you've learnt in year 8 so far. You've learnt integers, you learnt fractions, and you're now combining that with algebra and BODMAS to make sure you don't make errors. So it's not the theory. When I'm speaking to you, it's not that you don't understand what you need to do. What will differentiate between all of you is how good your times tables are, how good is your BODMAS, how good is your integers, how good are your fractions is what separates you all. It's not the theory. Mathematics has always been easy on the theory, it's the delivery. So the more you practice, the better your integers, your foundation,